Oh no.
I'm sorry. Oh no, not again.
Oh yeah, go.
Are we live or not? All right. So hello everyone. I'm sorry for the small delay. So I will give you a short introduction together with Torsten on our small RSLK kit, which means robotic system learning kit that you received previously. So as said before, Torsten and I are both field application engineers. So let's quickly go over the robots and how to work with it. All right. So for you to get started, you first can unpack your robot. And when you do so, you will find a small USB stick in the package. So for this one, please do not throw it away and secure it safely somewhere in a close reach to you, because you will need it later when Torsten will go over the programming part of the session. So first to start, I hope that every one of you has a MyTI account and you registered at ti.com, because you will need it. So to get access to our coding program, you need to click on the link right now. And I will open it here. All right. So if you manage to do so, you can now get access by logging in into the web page. And here you will see the install the CCS Cloud tool. So please click on it, and I hope that you will be able to install the program in less than a minute. When you did that, you can start the cloud by clicking on this link, but it will pop up later in the session as well, so you can wait a little bit. For you to get a short invitation or introduction to our robot, you can click either on this link or in the link below to get familiar with the user guide. So because I have no camera, I will give you a short introduction on the robot based on this slide. So as you can see here, your robot has some bumper switches in the front. It has some line sensor array that will make possible for you to program your robot to drive along some line, and Torsten can give you a short introduction on it later in the session. On the top, you will have a board with two microcontrollers, one for the debugging and one for the programming part. They also have two wheels and motor to drive them. There's also a tachometer involved for you to be able to measure the speed. All right. So now I hope that you have your robot right in front of you. Please position it somewhere where it will not bump into something else, because we will start the robot in about 30 seconds. So first of all, I would like for you to turn the robot around and to put the batteries inside. When you did that, please put the robot back on, and you will find here across the bumper switches the power on button. So when you place your robot the correct way and the batteries are on, you can now push the start button. You will see a blue LED lighting up. It should be somewhere here, which means that your robot is now turned on, and your robot is supposed to drive for around 10 centimeters in the forward direction. So now you can turn it off again, and we will proceed to connect your robot to the programming tool. Also, please turn the robot off. All right, so here's a short introduction to the programming tools. We will work with the CCS Cloud, as mentioned before, and you can find it by clicking on this link.
Maybe, this is Torsten, maybe you want to give the participants a chance to try run with the batteries mounted, and maybe we get some feedback over Discord whether it's going to run or not. Should we do that?
Oh yeah, that sounds good, Torsten.
Just to give people a little bit time. I see Discord here, I'm seeing interaction. People are trying to find and see the stream on YouTube. Let's see whether we get feedback over there.
Yeah, let me know if you see anything popping up, and then I will continue when everyone is set up.
Yep. So I see people
Any updates?
typing. Yeah, I see people typing
Mhm.
in Discord. Some people are typing. Let's see. But just a question to the audience again. Can you get the robot to move?
I feel like we need some music for the waiting game while everyone is setting up the robot.
Oh, someone is asking where the switch is to turn it on and off. You
Oh,
may
okay.
want to go back to the slide.
Sure. So you see here the bumper switches, and if you position them in front of you, the turn on and off switch will be right across them. It's here.
Okay, we have received first feedback. Juliana says, yes, it moves. And yeah, Ahmed even says it moves. Yogesh
Okay,
said
that
LED
sounds
is on
promising.
but not moving. Yeah, for some people it moves.
Okay. But we pre-programmed all of them, right? So they would have to move, except
Yeah.
there's no program on them.
Yeah, they should, all of them should move. Yeah, then Nijira says mine moves as well. Fantastic.
Mm-hmm.
Hi, this
Okay,
is
so should we
Christian.
Yes,
This is Christian. All robots are the code is on there. They all run in the test before we ship them. The beauty of this live stream is that people can watch it afterwards as well, right? So what I see on Discord is that most of them run. For those people where the robot is not running, we're happy to come back to you after this session to see where if there might be some technical issues, right? Thorsten, it would be cool if you can help
sounds
them
good.
then with that.
Yeah, Alicia, prior you proceed, in particular for Yogesh, because he responded his robot is not moving. In a next step, we're going to reprogram all robots anyway. So let's take that as a debug step. So keep going, even if the robot doesn't run, doesn't move. Watch for the next steps to be made, and we get it running. Okay.
All right. Awesome. So as next step, we will connect your robot to the computer. And you will find here the small USB port. So please connect your robot to your computer by connecting the cable to both of the USB connectors. And once you do that, let me actually show you by connecting my robot. A green LED will pop up. It is somewhere here. And when you did that, in your DevTools, you will see here that the board has been found and acknowledged by the system. So as the next step, you can click on CCCS Cloud and launch it. And it might take a while. I hope your connection is faster than mine. Otherwise, it's about 10 seconds of waiting for the server to start. And waiting once more. And a little bit more. All right. So when the window opens, I have a lot of programs already here, but this should not be any of your concerns. So I hope your robot has been identified. If not, I can show here. You can click on new CCS program. So let's just go along with it. Create new CCS project. And as you see here, since my robot has been identified, it will pop up here. Otherwise, you will have to search for the right microcontroller in the database in here. So once you find it, you can start with a project name, let's say Move Robot. those settings should be set by default, but if not, you will find them in the PDF accordingly. So you can click on Finish Now, and your Move Robot program will open here. So in the main C window, this is the window where you will be able to program your robot. Now moving back, some small introduction to the robot once again. So as mentioned before, it has 2 DC motors, it has tachometer, it has 6 bump switches that you can see here. So you can program your robot, for example, to bump on an obstacle and to move back. You also have the photodiodes and of course the MSP432 launchpad that will be able, or that will make it possible for you to program the robot. And of course, any additional attributes on the board or within the MSP432, like digital to analog converter, op-amps, timers, USB connection, as mentioned before. And it is possible for you to connect any other sensors or even microphone sound detection, but this is something more advanced, and I think it will not be covered during the session, right, Torsten? And moving next. So if you want to program something additional, you will find this pin map within your package, as well as when you click on this link. And for example, here you can see, if you zoom in, pin 2.7 is pin 2.6 for PWM of the wheels to make the robot move. So if you need any assistance on that, the coaches will be happy to help you with recognizing which pins will be the right ones for you. And I will then give the ball to Torsten to introduce you how to program your robot.
Okay, thank you very much, Alisa. Very, very good. Very good. Well done. Let me share. Okay, I'm sharing now the second part of the presentation inside the PDF document. Before I proceed, I want to give you a little bit of time again, get yourself set up and orientation for yourself. As I'm watching the Discord thread, I just want to ask you, just forget all the many folders you see inside my CCS Cloud IDE. If you just created a new project, as Alisa said, and she pointed to the first main.c file that will be open, we see almost no code, so it's empty. So here my question, are you at the same point? Can you see this? Have you been able to create a project and it looks like this?
You can also answer in Discord, so we can see if we're aligned or not.
Yeah, please send a message if you're fine. Yeah, Mayara is fine. Juliana, fantastic. Mayara, perfect. I know all this takes time, in particular if you do it the first time. Then many things can happen. Whatever, computer, then understanding, because you have to listen and acting the same way and things. I know it is complicated. Perfect. Juju says yes. There's a delay in the YouTube video. Okay. Okay, so going back to CCS Cloud, let's stop here with programming the CCS Cloud. We will come back to this, but first I would like to introduce you into robot software, like kind of code, and why the robot moves, and then extra or additional examples what the robot could do as well. Okay, we go one step ahead. As you have the robot in front of you, and Alicia pointed to the two motors in the white enclosure mounted right on the left, on the right, connected to the wheels you can find there. These two motors have technical connections. There's a motor inside, there's a tachometer, as you see as the black wheel close to the little connectors of the motor itself, and they have a meaning. If we look at it, we find here in this slide, we find ports P54, P27 and such. These ports are the ones that Lisa highlighted, and we call it ports, and per software, you can program ports as you give namings like P, but what does it mean? The microcontroller drives inputs and outputs and gives naming P for port, but it routes out to the PCB board. And as Alisa showed, these kind of connectors you have seen, they have different namings. They called J3.29 or J4.40. These are the physical connections. Just to be aware of that. We do not have to take care of it for now because all of the robot is mounted and ready to go. But keep in mind, a P, like a port, such as P5.4, is something I can drive or read out via software, and it goes out to a dedicated physical pin. So whatever you connect with it, it will behave this, like it will react, let's say, according the software you are using. So now, looking at the functionality, the motor. So the left motor direction, so the direction, so which way the motor should turn is connected to the port P5.4. So if you use this in software, it will make changes to the direction of the motor, the way it spins around. On the left motor PWM connected to port 2.7 is actually the output at which you control how fast the motor should run. So the speed of the overall robot will be impacted. PWM means pulse width modulation. It is a frequency kind of signal that you apply to the motor. And depending on the frequency or duty cycle of this signal, motor will be spin fast or less fast. Okay? Then left motor enable is connected to the port P3.7. Here, finally, you enable the motor. So you can choose the direction without any impact to the motor. You can choose even PWM, so the speed of the motor, but you have to enable the motor prior the motor starts to move, to spin, right? Same thing on the right-hand side. You just have different ports, P5.5 for direction of the right motor, P2.6 for the speed of the motor, and P3.6 to enable the motor overall. So now, keep in mind, these ports or little, like, let's say, signals are important to make the robot to move. If I now going over to software and first of all want to introduce what in initialization phase you have to do first of all. It is done in software, but I want to show, explain what it's good for. The P5 direction is a whole register, 8 bits. As I've shown you, port P.4, P5.4 is just a single bit out of a whole 8-bit register. So if you want to set this pin as an output so you can drive something instead of reading information in, you have to set this number into a register. So in particular, we want to make the port P5.4 and P5.5 to become an output, because that allows us to control the direction of the motor. Then we want to make the connections P2.6 to P3.7 to become an output. The same way. So different numbers by the end. So this is 6 and 7 instead of 4 and 5. So here's a misprint. So it needs to be named P2. I have to rephrase that. So you write this number to the register, and these bits become out, or these pins become outputs. Same for P3. So to program P3.6, P3.7 to become an output, write C0 to P3 direction register. So next, you have the P5 out register. P5, as I said, is for the direction. So what you do is you write 0 into the register P5 out to make the motor to go forward. So both motors, the left and right motor, to go forward as soon as you have enabled it, for sure. You program the P3 out register to set P36, P37 to become high, to disable the sleep mode, so motor becomes active. And now finally P2 out, you write 0, which means motor do not move. So motor stops, but direction has been set. So maybe that confuses you. If so, then let's redo the same thing and explain what we have done. For example, the output registers P out are the ones that can drive a pin, for example, to the motor, high or low. If we program a bit to 0, then this pin will be low. If we program a bit to 1, the pin will be high. So why such a number? This is a hexadecimal code. So the hexadecimal code works this way. You have a register 8-bit wide, so from bit 0 to bit 7. You have register values, so we call it the 8421 code. Each pair of 4 bits form up a nibble. That's what it's called. A nibble means 4 bits out of 8. The nibble goes from 8 to 1, and the lower nibble as well. So if you ask, why is it C0? Because the left nibble owns 2 bits being 1, 2 bits being 0 or low. And if we sum this up, 8 plus 4 is 12, and 12 in hexadecimal is C. And as the right, like the lower nibble, is 0 overall, you see the number 0. So this is the same, like this is the way it works. And for direction register, the direction register is handled the same way. If you can use the P3 out register to drive the motor or to make pins to be high or low, but first of all, you have to set up the P3 direction register. Otherwise, this pin is not an output. It will become an input, and you can't drive input pins. You can only drive output pins. So think of, if you want to drive a motor, this pin needs to become an output out of the direction register. If you want to read in something like a switch or something, it needs to become an input instead of an output. Otherwise, you will never be able to read. Okay, I hope that helps a little bit. So now, why is a motor spinning? Just want to explain. What is the software code that makes the motor to spin, and how can you control the speed? And how can you program how long the robot should move? As you have seen on your desk, as we had the first test run, the motor stopped after whatever, some centimeters, because a time has been count down and time was over. However, let's think about it. Think about a little piece of C code. It begins with the wording while. And it says, do something inside the braces so as long as a variable called so a C variable called I its content is bigger than 0. So this code will be executed again and again and again until the number, the content of the variable I will be 0. So the code, the processor jumps into this code, it enters the while loop, it waits for sometimes here for 5 cycles, like processor cycles, so it does nothing. Then it puts both pins P2.6, P2.7 puts to high. That enables the motor and gives them power. So motor begins to speed. But in this line here, exactly the line I'm pointing to, P2.6, P2.7 set too high will make the motor to spin as hell. So it will run very fast, much faster as we want them to spin. So what do? We just keep this pin high for one processor cycle, and after we turn off both the pins totally. So we set them low. So the motor should stop. We decrement the variable I, and the while loop returns to the while and enters the loop again. We wait for a delay of 5 cycles and we turn on the motor again. So now look at this. If you just look at the while loop and you watch out for the delay cycle, which is 5 cycles, but the on cycle, the on time is just 1 cycle, and then the off time is 1 cycle plus the other 5 cycles. That will create such signal, a PWM signal where most of the time the motor is off power. So motor is off. Just 1 cycle, motor is on. So, and that ends up into intermediate speed. So it's up to you how fast you want to run the motor. So the matter of cycles you wait, so delay cycles, will control motor speed. So coming back to the while loop, again, you turn around the while loop until the variable I has been expired and is 0. So what's next, right? So you would leave the loop, and the motor will not run anymore. Will just stop. So the time, so the duration for the overall robot to move is limited by I. So once again, motor speed is controlled by the ratio between the delay cycles and the on time. So this is the motor speed. but the overall robot movement time is limited by I. Okay, let's go to the overall code and explain, because that is the code which is currently on your robot. That's the way or the reason the robot moved, and we will copy that again and give you a dry run with CCS Cloud. So let's get started again, just to make sure we all understand. At first, you always start with main. Main is the main entry point for any kind of C code. And if we go back to CCS Cloud, you see there will always be main. Main is the entry point of your individual software application. And the end of the braces, for example, here is the end of your code. So if your program leaves this braces here at this point, then code is running out and you are in idle. The controller does nothing anymore. So going back, let's recapitalize. Forget the watchdog timer, it doesn't matter, it's not important. What is important is to revisit what I've explained. The initialization phase ensures that all pins programmed to become outputs and set up the right way and make sure motor is off and such. But then you enter the while loop, as I explained. And here you can see the variable I is set to 100,000. So 100,000 times this while loop is going to be processed and will make the motor to move slowly, because we have introduced 5 delay cycles, right? Okay. Now, this is the same thing, but just for you as a help. In its initialization phase, as I discussed, move robot with limited speed for certain distance or time here, and then stop robot. Stop robot, again, as I said, final braces passed means motor program is over. I would like to ask you now, if you go and copy all this code, you can either copy the code or you can make use of the C files that are already part of the USB stick. So up to you. You can copy this code, you go back to CCS Cloud, and you mark everything you can find under C, everything, and you paste over. Yeah, that doesn't work really. Then let's use your code. Use the one from your USB stick, or the one that Christian shared, for example. Here, this one, the robot move. Download this. Let me do that. Now it's here. Now it's here. So this is my text editor. I'm taking the code, copy, go back to CCS Cloud, and delete everything and copy this in. So now, before we proceed, just try to find your way to copy this code in your project that you have created. And
there was a question on Discord.
oh,
which device should I choose while creating a project in the CCS Cloud?
oh, please repeat, say it again.
Which device should I choose while creating a project in the CCS Cloud?
Very good question here. please pick the device MSP432P401R. It may be helpful to find the device if you go to the select filter on the device and go to the MSP432 family. Then it limits your choice. Okay. Mm. Okay. Okay. Good. Good. Just let's give. Just want to give you a little bit time. It's a lot of stuff. So before we proceed here, go back to the tab TI Development Tools, as Alisa presented. On the left-hand side, you see whether your robot has been detected or not. If I disconnect my robot, let me do that, it disappears. No device detected. If I reconnect my robot by just plugging in the USB cable from my computer into my robot, then the site detects my robot, and that indicates I'm ready to go. Okay, so now as we have placed the first code into our new project, we would simply press run. It will not make the robot to move or move away or does something. What it does is it compiles the code so that machine code will be created out of it. And then it transfers the code onto your robot. It will overwrite your existing program, actually with the same program, because this is the code that used to be on your robot as you unboxed it. So this is the code that was on it, and you just overwrite it. So by the end, the robot should move the same way as first time. So let's hit the run button. And then we should probably, give people like all of you chance to replicate, to do the same thing.
Torsten, there is a question as well on YouTube. So Ingrid says, for me, it says that I should install TI Cloud Agent, which I did, but it's not detecting it.
So two things, good point. If I'm going back, if you connect your robot first time, or prior you connect your robot first time, whatever, you have never connected your robot to this site, to this site, to this site, then you should see two buttons. One is called install, the other is called download. You should exercise both of them to ensure you have all drivers and plugin installed correctly.
Yeah, she said, I see I should move it to app local, and she's trying that now. So
Yeah.
she's trying exactly that.
I know it is a challenge, as every computer may be different, and issues you probably see. However, don't give up. We will help you anyway later on. So just to highlight, I did press the run button and the code had been transferred. There is a warning, but forget the warning. Now, as if your CCS Cloud completes the process after hitting run without displaying wording like errors here in this black area, your robot had been reprogrammed automatically. If you now plug off your robot from USB, so you just put it off, so you can see that in DevTools on the left-hand side, it disappears. And now you would click the same power button that we have discussed at the very beginning, the robot should move. So it should move the same way as it did first time. Now turn off robot again after with the same button and plug in the robot to your computer. So now let's go over to a next example. Probably it's a good idea to show and explain the 3 different examples I have with me today to get an understanding of it. Even you have still trouble with your robot, that may happen, and get the understanding, and then we do debugging after. Now, the bumper support. Bumpers are the ones, as Alicia explained, on front of the robot, the 6 switches that will be read out by the microcontroller. So it allows you to get notified if robot bumps against whatever obstacle, reads it out, and can make, for example, the robot to change its directions, to overcome the obstacle, whatever. Let's explain how it works. You have 6 switches, 6 bumpers. These are sensors. So it goes from port 4.7 down to port 4.0. So 6 bumpers from left to right. But this time you have to read in data. Instead of driving a motor, you read in switches. So that's the other way around. Therefore, the port 4 needs to become an input across 8 bits, for example. We just need 6, but 8 bits. So we program the port 4 direction register to 0, meaning all these, let's say, connections or pins to become inputs. Otherwise, we will never be able to read data. Port 4 out is usually to drive the out register is usually to drive pins, but as we have programmed these pins to become inputs, what you can do is you can activate pull-up mechanisms Why? I tell you why. The switches here, the bumpers, if they get touched, so you switch it, then you can just put a signal which is 5 volt down to ground. All you can do. This is all you can do. If you have a pull-up resistor active, then you ensure that the input voltage to the switch is always 5 volt and not 0. And the switch makes it to become 0, so it drops down the voltage. So you, in the initialization phase, you make sure that you set the pull-up function to all these pins. You enable the pull-up functionality, and you make all these 6 inputs here in this example, 8 inputs, but we just have connected 6 switches to become edge sensitive. Why edge sensitive? This is for the reason of interrupt detection. I explain this later on. So you configure with P4 IFG, you configure this register to clear all pending interrupts. I will explain this in a second. We will enable interrupts. So the interrupts that, or let's say if the switches switch, or one of the switches switch, or all of the switches switch on port 4, then we will create an interrupt in the processor so the software can act accordingly. I explain this later on. So then we enable interrupts. So first time we use some of the pins as inputs and not as outputs. Why? If we go back to the initial code we talked about for making the robot to move, I explained there is the main function. We pass code, so the microcontroller executes the code it finds for a while. For example, here until something is true, or as long as something is true, and then it goes out. So all of this is controlled by the microcontroller executing its code. But we do not want to read out the switches all over the place because it just goes on cost of microcontroller resources. So it would keep the microcontroller busy. We don't want this to happen. What we want is that the microcontroller executes its code, and whenever one of the switches get hit, then we want to enforce the microcontroller stop executing its code and execute different code. If you look at this area, this is a function called an interrupt handler function. This code will never be executed from the controller unless one of the switches is hit, so that the switch enforces the processor to enter this function wherever it used to be before. So push one of the switches results in a jump to the interrupt service routine. This is what it says. And it executes its code. What does it do? First of all, it does nothing more than it writes the number 30,000 to a variable called cycles. This isn't kind of an initialization. We need this later on. The same way later on we need to program the hexadecimal number 10 into a variable called direction, and a C0, hexadecimal C0 value into a variable called drive. And then we are calling a sub function, a subroutine. This is the interrupt service routine we got jumped into, but this interrupt subroutine will call another function. It will call drive back. So here it will execute this instruction, drive back, and will jump to this code for execution. And here we need these variables. So we have programmed these variables, cycles, direction, drive, and such. And here we program this. We take the content that we have programmed in direction, for example, and copy this into a register called P5 out that we discussed already. P2 out, we drive this, and then we write 0 into P2 out, and then it goes around. So what is it? This one here is the same as we discussed earlier to make the robot to move. As I said earlier, this delay cycle controls the speed of the motors, while the while loop tells you or helps you to drive the overall robot for a period of time. So this is drive duration. So now going back, drive back. So what does it do? The switches, so the bumpers, one of the bumpers are active, as you can see here, bumper 0, P 4.0, for example, hits, and we enter the interrupt subroutine. The interrupt subroutine calls drive back, and this function will just make the robot to move a little bit, but backwards, and then makes the robot to slightly ride a little curve because one motor is off, one is on. So this is the significant, or these are the significant functions to be looked at if you want to use the bumpers, you want to steer the robot, want to make the robot to move around an obstacle.
Torsten?
Yes.
We had a question, so could you explain again the pull up function?
Yeah. The pull up function. Yeah. So such a bumper switch comes with two connections. We see three, but let's just discuss two connections. One connection on the one side, other connection on the other side. And if you use the switch, you will close the circuit inside the switch. So both the connections of the switch will have a shortcut, so they are connected then. As soon as you release this bumper, this connection will be gone. So the only thing you can use, or the only thing you can reach with such a switch, is to close a circuit. That's it. So how can we make use of it for our bumper mechanism? If I program some of the pins to become inputs, usually they begin to float because input pins are of high impedance, not stable, because I want to sense something. So I want to sense in a way of I want to read in what's outside. So if you, as soon as you program this to become an input, it will float. What does floating mean? Floating means the electrical signal bumps between ground, so 0 volt up to 5 volt and back to 0 volt, and it will have intermediate voltage levels in between, in a very random scenario. We don't want this to happen. We want stable conditions that help us. So if I program this input pin to become a pull-up function, that means inside the chip, inside the processor, there is a little resistor which is mounted to 5 volt. And if I do that, as soon as I program this pin or these pins to become inputs, they will be high, but just slightly high. So they will show up 5 volts, but as soon as you close a circuit, which you have, like you put them, let's say, to connect ground to this input pin, you will not cause high current or a shortcut, what you will do is you will just pull down this 5-volt input pin to become 0 volt, so pull it to ground, and your processor is able to read the value 0 in. So this is what the pull-up function will do for you. It makes or ensures, the pull-up function ensures that your input pin is not going to float. It is at a steady, stable condition, 5-volt in this case, and just waits for a switch to pull the 5-volt down to ground. And no overcurrent will appear because there is an internal resistor that restricts high currents. Okay? But for now, I would recommend just leave it as is, because there's anyway no option. So it is initialization. So now you know pull up is important, but as just never change that. Okay. So this is for you to read. So you can later on read this. There's the code as well. And how do you use this code? Let's practice. This is the code we have pasted in 20 minutes ago. Now we overwrite the new code. So what you're going to do is you go to your Discord thread, you go up to what Christian was posting, and you download the bumper interrupt.c file. Just click on download. It should be download. And you, wait a second. You open the c.c file and you see more code. Why? Because the initialization phase, as we discussed, we enabled interrupts, and we have the while loop, first of all, initially to start the motor to move, and the motor moves as long as there is no interrupt. As soon as there is an interrupt coming up, this function will be called. It will reinitialize the motor and then will make the motor to turn back in order to drive around an obstacle. So what we're going to do now is we take the whole code, everything, copy, go back to CCS Cloud, and mark whole existing code, everything, and we paste this new code in. That's all you need to do. If your robot is still connected with your computer, you will see this here. If this is the case, you hit the run button. Now, this code will be compiled to become machine code and then transferred over onto your robot. Again, it completes, hopefully without any error messaging. Oh, yeah. Okay. So now your robot has been reprogrammed. So now if you now disconnect your robot, so as you can see on my page here, no device detected. So I have connected off. If you now turn on your robot, make sure it does not fall down your desk, because it will go until it touches any obstacle, and then it will try to overcome it. Give it a try, and then take the robot back and turn it off. So I should give you some time now, I guess. So now it's 3 o'clock, so 1 hour we have used. How much time do we have? Let me check. Yeah, we have 1 other hour. Very good. So now I give you some time. Take your time. Try to do the same things and give me feedback, whether it is like you can see the motor to work or not. I see just questions from Britta. Energia IDE. So Energia, it should work.
So somebody in Discord said it worked for her, Mayara.
Yeah, Mariah said it worked. So now your robot, it moved, it tries to find its way around an obstacle. Isn't that somehow intelligent? It looks like, hey, this is my vacuum cleaner, right? So I just want to give you some more time for some other guys to get this to work, to play with it. One question to the team. I'm running Discord in my browser, so it seems to work along, and I'm running Discord on the Discord app, but this is not updated as on the browser. I don't know. What should I do? Any idea what I can do?
I think the app should work better than the browser, right? If you have both, I think the app should be better.
Yeah, but the on my maybe I don't know whether I did something wrong. It's not really a very problematic thing, but so there's something like Clyde reported 2 p.m., but here is 3 p.m. So Nigeria, this seems to be updated more quickly or at all, and the other not. I don't know, but maybe it's a configuration thing.
Mine is not reaching to the bumpers. Stopped after a few seconds as before.
Mine is still not reacting to the bumpers. Stop. Ah, okay. Yeah, see, the browser gives me latest information so far. Well, I can figure that out later on. However, yeah, so what is it? If you copied whole program, so whole code to your project and you run, I'm not sure whether you saw error messages here. Like, yeah, all 0IO. Try to reach the switch close to the power. The switch. There is a switch. This is true. My switch, so let me show this. There's a power switch and there is another switch. My switch is at that position. So it is, if we look on from this perspective, it's on the right. And if you hit the button, it should run. If you hit the button again, it should be off. So my switch is at the off position. So if I'm looking at that switch here, so this one, so then it should be in the off position, if this is the point. So in case your robot does not use the switches, but it moves the same way it moved from right at the beginning, then at least it tells you the robot is working, but you have not uh, programmed the latest program, the bumper program. That is what it means. It means robot is working, but the latest code had not been transferred. Okay. Okay, so Julio mentioned, so now it's worked. It worked. So okay. So now, for all of you who got the robot to move and who got the robot to be reprogrammed to use its bumpers, you're ready to go for programming and do everything you want to do with the robot. I have a third example, but usually I stop at this point just to give you time to rethink. All right, so you have enabled the tools, so CCS Cloud in that case, so the tools to that allows you to program at all, with examples that shows how and where to make changes to make the robot to behave differently. So that opens up creativity. And then you have the presentation that explains again to why the robot can be programmed and why the robot is moving and all of this. All right, so what I can do is now let me show you the final code. Then we have still time to whatever for answers and questions and things. Okay. So let's review a third piece of code just to increase or enhance creativity here. The line follower. The line follower program requires you to place a black line onto your floor. Probably better not on your desk, because that could be risky, because the robot can drop down if programming is wrong or something goes wrong. So if you have, let's say, for example, a Scotch um, Scotch in color black or something in black, then you can fix a black line on your floor, and you can try to make the robot to follow the line. How does it look like? Give me a second to show this up. So if you would have such a black line mounted on the floor, in best case, a bright background. So black floor on black line, not good. So with help of this program, the robots can move and follow the line, right? So this is the idea. Okay. To explain this, underneath your robot, there is a line of photocells and LEDs. It is the one that Alicia mentioned right at the beginning. Here. So if you have your robot, you flip it around underneath, you see a bar of photocells and LEDs. That's the one we're talking about. 8 photocells and 2 LEDs. This is the black line here, an example of a black line, white background. You see the bar, the black bar twice here in green. And you see that as we have 8 photo transistors, we get 8 bit of information, which fits into a standard register. We have a left nibble and we have a right nibble. And you can see here on, for example, position 7.7 on the left, the content says L for low because there's no black background, there's white background. While the photo mechanism here, this kind of bar, makes the bit to become high or the pin to become high, like 7.5, if you have black background underneath. So this is the way you can steer your robot, or your robot can be steered by a line. So how does it work? So there are 2 LEDs that will be turned on for brightness, helping the 8 phototransistors to better read in, to have better quality, to read in whether the background is black or the background is white. LEDs are connected to the connection P5.3 and P9.2. The 8 photodiodes are connected to the port P7. So what is happening? If we look at the code, by the way, here you can see the while loop contains the number 1. While 1 means this code will be executed endlessly, will never stop, because it will execute until the statement in the brackets are true, and they will always be true because we have put in 1 manually. So what is happening? You program the port P5, and in particular, you set the P5.3 pin to become an output. So it drives an LED. Then you program the P5 out register bit P5.3 to turn on the LED. So again, 2 things. First of all, you have to make it an output and not an input. Second, you turn it on. Then you make the same thing with P9. You make it an output on P9.2 and you turn it on. Both LEDs will be on. Now, what you're going to do is, first of all, even though you want to read in the photo transistors as you did for the bumpers, but first of all, you have to load a capacitor. So you program the P7 to become an output and you turn on the output. So it sounds confusing, but even you have connected photo transistors, they have connected a capacitor as well. So you want to load the capacitor. So you load the capacitor for a while, in particular for 10 cycles, as the delay cycle time is 10 processor cycles. Capacitor is full. Then you turn around the input-output characteristic to become an input. From now on, you can read out the values. So you read the values of P7, and then you turn off the LEDs. This is the way it works. And it works endlessly because, I mean, you want the robot to identify or measure the line on your floor all the way. This is the code. And the code is split into several conditions. You have, let's say you have readout data, which is the data coming from the 8 phototransistors that will be stored in variables, in temporary variables. Just as an example, if readout is 0, so if this is true, the motor will just run. This code you have seen already right at the beginning, at the robot move example. It does nothing more than turn on the motor and let it just move slowly, but no steering, nothing at all, just let it move. Because no readout, if it's 0, there's no information in the variable readout. The robot should just move straight ahead. And then you have different conditions. But if you read out the values of the 8 phototransistors, you can split this down into 2 nibbles, and you can measure them separately. So the left area and the right area. The left area and the right area. And upon that values, the robot will either steer to the left or steer to the right. So this is one steering action, and on the next slide you see another steering action. So left and to the right. So, and that runs all the way, and that enables the robot to adjust its directions up on the line itself. So the code is explained here. So you can use the same code if you like, but I'm not sure whether that makes sense right now. You may want to play with this later on, or you want to proceed with the brainstorm session, no problem. But just to let you know, you copy the code same way in CCS Cloud and run, and we'll see the same. You will see that the robot is trying to search for a line, but if it can't find a line, then it will just go ahead and endlessly and will never stop. In this code is in Christian's final file, line follower. So you have this in your, as part of your USB stick, same thing is here. All right, good. So I would stop for now and just give you some time and think of some questions, whatever. Play with the robot. So let's see. So I'm giving you some more time. Play with it around. You may come up with questions. So there's a question, why is it moving in circles? Yeah, this is something we can talk about, or you find this out. We can do that. So why is I assume you talking about the bumper example. So why is it moving in circles? Let's wait a minute, and maybe someone of you wants to respond to this, because whatever you have an idea. Otherwise, I will explain that. Okay. That someone is typing. Oh, why the line follower is running in circles? Yeah, depends on your floor. I would assume that the robot is indicating always to be like steered to the left, or always need to catch up with a possible line further on the left. That's why the reason it goes in circles. If you have a proper line, so a black line on white background, it should follow the line. As far as I should do that. Um, Looking at the line follower code, there's one condition that says first P 2.6 and 2.7 set to high, enable signal for left and right motor, and then you make a change. That will make the robot to go to the right. But this steering step will just occur if the readout value left is bigger than the readout value right. So enable signal for right motor. So it just might, no, it will turn left because the motor, right motor is on. This is the opposite condition. It will enable the left motor. So it turns the other way around. So if you do, if the robot just ends up always with the same number, for example, readout left is bigger than, greater than readout right, it will just cycle cycle around, just in a circle. It's at least the logical answer to your question. All right. So I'm just waiting for your questions. So from the technical perspective, we're almost through the training and happy to see how it works. Yeah, exactly. Yeah, Maya, yeah, there will be questions as soon as you try to implement your own ideas, because then you may have questions such as, I want to do this, what code should I use? How can I reform the code so that it does whatever I want the robot to do? Yeah, true. So, Christian, I'm ready here. So I'm ready even to receive additional questions, but seems to be fine so far. I don't know. What can we do?
Thank you, Thorsten. Thank you so much. That was super interesting. I read a lot of positive messages on Discord. People are interacting there. It seems to work. It seems that everything is set up. Let me pause for 1 or 2 more minutes just to see if there are no more additional questions coming up. And then in maybe 5 minutes, I'm happy to take over for the next part. So let's wait just a few more minutes and then I'm happy to take over. Okay?
Oh, yes. Yeah. Good plan. Yeah. Thanks, Nati, for, yeah. Thanks. You appreciate what we have presented here.
And I'm happy, Thorsten, to already take over the screen if that's fine for you.
Oh, yeah. If you like, sure.
I just grabbed the ball.
I can't really see whether guys have difficulties, because it seems to me they are in different rooms and things, and I lost a little bit track of that, but seems to be the coaches are very active here.
I will be back in 2 minutes, 3 minutes.
Yep. Okay.
All right, everybody. Are we ready for the next part in the agenda, or are we in need for some more time? Maybe someone from Female Tech Leaders, if you can help me here. I'm happy to march on, but we can also wait a few more minutes. Please give me some guidance on that.
From my side, it's fine. I think there was one question on technical support.
Cool.
From Alisa. So how to specify which function runs when an interrupt is detected.
All right. Thorsten, can you still do this one? And then after that, I'm happy to follow up.
I did not catch up this. What is that?
On the technical support?
I am happy to just take it in the chat. So I'm already typing if that's fine, or should we answer vocally?
It's up to you, I guess. You can answer on chat as well. So we can move on.
Okay.
Good. Thanks. So Christian?
Yes, then I'm happy to take over. All right, everybody. Yeah, welcome back to the closing of day one in regards to the official agenda. So, it really was a lot, right? I hope it was all interesting. Thanks all the participants. Thanks all the speakers for your sessions and everything you did today. Let me turn on my camera as well. If I take a look at the agenda, this is where we are at the moment. Maybe we have 15 minutes up front, but that's fine. After I close the session, and I will give you an outlook on the next day as well, I will hand you all over to your coaches. I took a look at Discord already, and I've seen that all the coaches already connected with their teams on Discord. So around 4, it is the time to connect with them so that the coaches and the teams get to know each other and discuss whatever is needed. Please note again that there is a technical support from Thorsten and Britta during this time as well. So probably between 4 and 6. And it would be great if we can then deal with all the technical issues. So thank you so much so far. It has been an amazing ride, but there's more to come. So let me give you a quick outlook of tomorrow. So tomorrow morning, and I hope you all get some sleep, we will start at 9. And I'm happy to introduce the second day again. We have an exciting workshop coming up, a quarter after 9. 2 of my colleagues from GI will have a workshop about design thinking and how to pitch your idea. And this information, of course, you can use for the pitch later on today. Then there is 2 hours of working sessions. Our coaches are available in that time period as well. The same applies to the technical support. Then around 12, shortly before we have our afternoon break, we have a yoga teacher who will help us hopefully to relax so that we can go into the afternoon, where we have after the break have a final working session, and then we continue in the evening around 7 with the pitches, 5 pitches we have. I will talk you through that more in detail tomorrow, but the 5 teams can there pitch their ideas. The judges will take a look based upon the criteria as already discussed. And after a super short break, there is the award ceremony and the closing of that day. So tomorrow is exciting as well. We're very much looking forward to that. In case of any questions in regards to organization, I'm on a Discord myself as well. So please let me know, and we're happy to follow up. Thank you all again for participating. It has been super energetic. I'm still thrilled. Keep up the good work. I wish you all the very best this evening and afternoon on your projects. Please have a look at Discord. The coaches are already there. They're happy to connect, to help you, to guide you. I'm excited to see you all tomorrow morning at 9 again. Thanks, guys and girls, and see you tomorrow.